Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts related to the NavIC, or we can say that the IRNSS satellite constellation and its application. What is meant by IRNSS? That is Indian Regional Navigation Satellite System, which is also known as NavIC. So NavIC is India's indigenous satellite navigation system, which is developed by Indian Space Research Organization, that is ISRO, for regional positioning services. It provides accurate navigation, positioning, and timing information over India and surrounding regions, where NavIC stands for Navigation with Indian Constellation. So the system was developed to reduce dependence on foreign navigation systems. It ensures strategic autonomy and reliable positioning services during the emergency situations. So NavIC, which covers India and approximately 1500 kilometers beyond its boundaries. Its constellation consists of satellites operating in geosynchronous orbits or geostationary orbits. So NavIC supports transportation, surveying, mapping and infrastructural monitoring, which is increasingly used in remote sensing and GIS based engineering projects nowadays. Introduction to the IRNSS. So Indian Regional Navigational Satellite System, operationally known as NavIC, is an autonomous regional satellite navigation system that provides accurate real-time positioning and timing services, where the legacy is dependent on the remote sensing, Indian remote sensing. Here, the evolution point of view, the IRNSS is evaluated with reference to the building on ISRO's legacy of remote sensing satellites, which are utilized on the basis of sun synchronous orbits for resource evaluation, where NavIC represents a shift toward geostationary and the geosynchronous architectures designed for continuous signal availability. Here, the IRNSS system combines satellite technology with advanced ground infrastructure. Togetherly, they provide continuous positioning and timing services. NavIC is specifically optimized for Indian geographical requirements where it improves performance and reliability across the region. So the technology supports transportation, disaster management and surveying, which is an important role in national infrastructural development. The need for India's own navigation system. Why India required its own navigation system? For three purposes, that is strategic independence, regional optimization and reliability. So basically strategic independence is the primary reason for developing NavIC, where India can maintain navigation services without external dependence on any country. Regional optimization, which improves positioning performances over all over India and the nearby India region. This system is specifically designed for local geographic conditions, where the reliable navigation services are essential during disasters and emergency situations. The NavIC ensures uninterrupted operation even during critical situations occur. Means the infrastructural development require accurate positioning data so that the independent navigation system supports national engineering projects and its completion in time. So real time data point of view or real time construction activity domain, security incentive domain, these are all the applications or benefits from the control and monitoring. So navigation data remains available for strategic and civilian use. Moving towards the service coverage area, that is the area covered by the IRNSS, that is the NavIC provides coverage across India and nearby regions as explained in the picture. That is the primary service area and the secondary service area. Primary service area is the Indian landmass, where secondary service area, that is boundary plus 1500 kilometer area. That area also cover the country like Sri Lanka, Myanmar, Bangladesh, China, Nepal, Bhutan, Pakistan likewise. Regional coverage, which ensures stronger signal availability, where the users receives more reliable navigation information within the target area. That satellite geometry is optimized for the Indian subcontinent. This improves positional accuracy and service continuity. Means that coverage includes land, coastal area, marine structures. So this system supports both terrestrial and marine applications at the same time. Here, engineers can use NavIC data for regional mapping projects, which is highly suitable for surveying and infrastructural planning purposes. So the regional focus point of view, a smaller 7 satellite constrained with 7 satellite constellation which provide intensity over a specific zone or area like primary service or secondary service, which contrasting with the 24 plus satellites at a time for the global coverage. The satellite constellation point of view, we can see that geosynchronous, geostationary satellites are there. These geostationary satellites are mentioned in the GEO location, which are exactly horizontal to the earth surface, where geosynchronous satellite are at the inclined angle of 29 degree. The NavIC consists of 7 operational satellites. These satellites provide continuous navigation coverage over the region. The constellation includes geostationary and geosynchronous satellites as shown in the picture. The total constellation of 7 satellites, where hybrid design ensures more than or equal to 4 satellites are visible from any point in the service area at all time. Here, the geostationary satellites remain fixed relative to the earth. They appear stationary to the ground observers, while geosynchronous satellites follow inclined geosynchronous path as shown, that is 29-degree inclination. This provides additional coverage and geometric strength. So multiple visible satellites which improve the positioning accuracy, where the better satellite geometry leads to more reliable coordinate estimation. Here, the orbit point of view, orbital mechanics, that is geostationary, or we can say that geosynchronous. So two orbits, geostationary orbit, geosynchronous orbit. So geostationary satellites orbit directly above the equator of the earth. They remain fixed over a particular longitude, where geosynchronous satellite orbit with an inclined trajectory. They are not exact uh, above to the longitude, where their ground tracks form the figure, or we can say that the 8 patterns which gives the exact information of that, or oblique angle images, or we can say that the photogrammetric images of the location. So geostationary satellites provide continuous regional visibility, which simplifies signal reception and tracking, while geosynchronous satellite enhances geometric distribution, which improve geometry, positioning and precision. So both geostationary orbit and geosynchronous orbit togetherly form a robust navigation architecture, which design is optimized for India's regional requirements. The frequency band point of view and signal structure way, the bands are divided into two parts, L band and S band. So here the NavIC operates primarily the L5 and S frequency bands as shown in the picture. L5, that is 1176.45 MHz, while S band 2492.028 MHz. Thus S band is in the ionospheric correction, where L5 band is for the civilian use or GPS compatibility. Means dual frequency operation is in picture, which reduces atmospheric errors and which improves positional accuracy without extensive corrections required. So L5 signal are widely used for navigation applications. They offer reliable performance for civilian users. S-band signals provide an additional navigational channel, which makes NavIC unique among many satellite navigation systems all over the world. So multi-frequency observations improve surveying quality, where engineers can obtain more precise, accurate geospatial measurements. So dual frequency, which is most important for the civilian activities. Here, the standard positioning service, that is SPS, which is available for civilian users, which provides open access navigation and positioning services, where the position accuracy is generally around 20 meters or better than it, where actual accuracy may improve dependency on receiver quality. So time accuracy supports synchronization applications with reference to the precise timing for communication and infrastructural systems. standard positioning services, transportation mapping and navigation needs. It supports both mobile and fixed location applications. With reference to the civil engineering projects point of view, it can be used that standard positioning services for GIS data collection, which is suitable for many standard surveying activities as explained in the pictures, for the transportation point of view, for the surveying point of view, or for the ships or any type of users on the mobile phone. Control segment, the control segment which plays the important role, which is shown in the picture with reference to the ground segment, the space segment, control segment and the ground segment. So the control segment oversees the building, launching, orbital positioning and monitoring of the system, which is explained with reference to the hierarchy. So the control system monitors satellite health and performance with reference to the ground stations and tracking of satellite operations. So tracking station collects navigation and timing information. This data is used to maintain system accuracy, where master control facilities process satellite observations recorded and corrections are generated and uploaded within necessary time. So communication links connect satellites and ground stations, where continuous monitoring ensures that the reliable service deliverability. The control segment maintains overall system integrity, and positioning accuracy depends on effective ground management positions. So what are the applications in all over India for that IRNSS, or we can say that the NavIC? NavIC supports transportation and vehicle navigation system, where the accurate positioning which improves route planning and traffic management. The system assists in disaster management operations for the emergency response. That emergency response team can access reliable location information. Power grid point of view, the synchronization benefits from accurate timing services, where accuracy improves operational efficiency and stability. Maritime navigation is enhanced through the regional coverage, where coastal and offshore operations benefit from improved positioning and services. So location based services support urban planning applications, where GIS platforms integrate NavIC data for spatial analysis. For comparative point of view, GPS and IRNSS is compared with reference to some features like constellation size in terms of satellite, orbit type, coverage and design focus. So with reference to GPS point of view, GPS is owned by the USA, where IRNSS is owned by the India. In constellation size point of view, USA GPS have 24 plus satellites, but in India's IRNSS, which is consisted of 7 satellites. With reference to the orbit type, medium Earth orbit is used by the GPS, while IRNSS use high altitude, that is geostationary and geosynchronous satellites. The coverage of GPS is global level all over world, but for IRNSS in India, it may be for regional purpose, that is India plus 1500 kilometers nearby length. So design focus of GPS is for the global average, while the IRNSS is designed only focusing towards the regional intensity, that is for the ionosphere focus. So while GPS utilization, it requires more satellites for global line of sight, where IRNSS concentrates its resources over a specific region for optimized performances. For civil engineering and GIS application point of view, NavIC supports geospatial data collection for GIS datasets, which accurate coordinates improve spatial analysis and mapping quality. Surveying and infrastructure layout benefit from satellite positioning, where engineers can establish control points, or we can say the ground control points, more effectively and efficiently. The groundwater and environmental studies use location based datasets, where precise positioning which improves resource mapping and its accuracy. Here, the construction monitoring requires accurate coordinate measurement, which is depends on the NavIC, which helps track project progress and field activities or ongoing site activities. So remote sensing data can be integrated or correlated with reference to the NavIC observations, which improves georeferencing and spatial decision making procedure. So the workflow, or we can say that the future expansion and modernization in IRNSS point of view, here the future upgrades which having the objective to improve system performance basically, where additional satellites will enhance coverage and reliability. It started from the NVS series, that is new satellite replacing aging units, L1 band integration where civilian interoperability with standard GPS chips, or we can say that the variables, expansion to 7 from 11 satellites, that is proposed constellation growth for wider coverage, and at the last, indigenous atomic clocks where self reliance in timekeeping technology, that is real time kinematics point of view, with reference to synergy with Gagan, that is GPS aided geo augmented navigation for aviation safety purposes. So indigenous atomic clock development is being strengthened with better timing systems which improve navigation precision, where integration with other GNSS system is increasing for multi-constellation compatibility. Modernization will expand engineering applications where future systems must support advanced engineering and smart infrastructure development. So summary point of view, IRNSS or NavIC, where 7 satellites, 3 are geostationary, 4 are geosynchronous, 2 services where SPS and restricted zones are used, strategic autonomy point of view which is independent of GPS, and the regional focus or area coverage is of India whole terrain nearby to the 1500 kilometers passage. So application which include surveying, GIS, transportation and disaster management, they support the system numerously for the engineering activities. NavIC strengthens technological self-reliance of India, which provide a reliable foundation for future geospatial development. Stay tuned guys. Happy learning.